Today we will solve a problem involving exact differential equation. So we're given by quantity of x squared plus y over x dx plus ln of x dy is equal to 0, where this is a condition of y of e is equals to negative e cubed over 3. So first thing we'll do is to isolate dx so that we have the dy over dx. So that is quantity x squared plus y over x plus ln of x dy over dx is equal to 0. So in exact dE, we will first test for the exactness. So the formula for testing exactness is given by partial differentiation of m in terms of y is equal to partial differentiation of n in terms of x. So if the value of these two is the same, so we have exact dE. So the next step is to designate the first term as m. So here will be m, and this will be our n. So getting the partial differentiation of m in terms of y is equals to partial differentiation of y quantity x squared plus y over x. So as you can see, we will differentiate these two terms in terms of y. So x squared here has no variable y, so it is considered constant. So the differentiation of constant is 0, so that will be 0. So the next term is y over x. So differentiation of this is just 1 over x because x is constant. So differentiation of y is power rule is just 1. So that is 1 over x. So next is we will get the partial differentiation of n in terms of x. So that will be partial differentiation of x quantity ln of x. So here, the partial differentiation of ln of x in term of x is just 1 over x. So as you can see, we have m, or our m is equals to n. So we have exact dE. So we have exact dE. So in order to solve this exact dE, first we will find the antiderivative of psi of x in terms of dx. So take note guys that psi of x or psi x is equals to m, and psi of y is equals to n. So getting the antiderivative of psi x in terms of x, we'll be getting the antiderivative of m. So that is derivative of quantity x squared plus y over x dx plus some function of y that is missing or omitted in the original equation. So you can use any variable in denoting your function of y. So I will just use here h of y. So now, so finding the antiderivative of psi of x dx, as you can see here, we can separate or integrate it separately. So integral of x squared dx plus integral of y over x dx plus h of y. So integral of psi is just y, psi x is psi. So the integral of x squared in terms of x is x cubed over 3. So we'll use the power rule. So plus the integral of, as you can see here guys, that y is constant because it is not in terms of x. So we can get it out of the integral sign and we're left with 1 over x dx. So the integral of 1 over x is just ln of x. So our psi value will be x cubed over 3 plus y ln of x plus h of y. So that is our psi. So in order to get the first derivative of h of y, we will find the partial differentiation of psi in terms of y. So that will be partial differentiation of psi in terms of y. Just copy the value we get from our psi, that is x cubed over 3 plus y ln x plus h of y. So we will derive x cubed in terms of y. So x cubed has no y variable, so this will be considered constant. So the derivative of constant is 0. So it will be 0 plus ln of x here is constant too because it is in terms of x. So derivative of y is 1. So 1 times ln of x is just ln of x plus h prime of y. So now we will equate h prime of y to the n value of the original equation. So that is ln of x. So as you can see here, guys, if we transpose ln of x to the right side of the equation, we will cancel this ln of x here. So that our h prime of y will be equals to 0. So in our original equation, or getting the psi, we find the first derivative of our h of y. But in our original equation, there is no first derivative. So to cancel the first derivative, we will find its antiderivative. So integrate both sides in terms of dy. So our h of y is equals to c. So plugging the value now of our h of y to our psi function. So our psi function is equals to x cubed over 3 plus y ln of x plus c. So psi xy is equals to x cubed over 3 plus y ln of x is equals to c. So now this is our general solution. So but we are not done yet because there is a condition in the problem. So we'll find the particular solution. So in order to find the particular solution, we will find the value of c. So finding the value of c, so we'll write psi is equals to x cubed over 3 plus y ln of x is equals to c, where y of e is equals to negative e cubed over 3. And our x is equals to e. So plugging the value of y of e and x equals to e to our psi function, that will be e cubed over 3 plus negative e cubed, that is our y, over 3 times ln of e, because we'll replace x with e. So that is equals to c. So as you can see here, we can cancel if we combine like terms. So this will become 0. So it's 1 times 0. So ln of e times 0 equal to c. So our c is equals to 0. So now that we got our c, we will evaluate it in our original equation to find a particular solution. So now that we got the value of our c, so we will evaluate it in our psi function. So this will become psi is equals to x cubed over 3 plus y ln of x is equals to 0. So in this case, we will find the value of y. So finding the value of y, that will be, so we'll be transposing x cubed to the right side of the equation. So that will give us y ln of x is equals to negative x cubed over 3. So in order to cancel ln of x here in the left side of the equation, we'll multiply it 1 over ln of x to the both side of the equation. So this will cancel. And y now is equals to negative x cubed over 3 ln of x over ln of x. So the property of natural log is that the constant in front of it can be used to become its power. So the final answer will be y is equals to x cubed, negative x cubed over ln of x cubed. So this is our final answer. So just remember that x must be greater than 0 to have no undefined answer. So our next problem will be in the book of elementary differential equation of Rainville Bidient 8th edition. So you can find this problem in page 34, number 19. So we were given by sine theta minus 2r cosine squared theta dr plus r cosine theta quantity 2r sine theta plus 1 d theta is equals to 0. So the first thing we do is to isolate dr. So we'll have d theta over dr. So that is quantity sine theta minus 2r cosine squared theta plus r cosine theta quantity 2r sine theta plus 1 d theta over dr is equals to 0. So just like before, we will test for its exactness. So we will designate the first equation as our m, and here our next equation as our n. So testing for exactness is using the partial differentiation of m in terms of theta. So that will be partial differentiation of theta in terms of sine theta minus 2r cosine squared theta. So here we will differentiate all terms with theta, and without the theta we will treat it as our constant. So the differential of sine theta will be cosine theta. So that is will be cosine theta. So here 2r does not have theta, so we will consider it as a constant. So we will just put it there. So in order to get the differential of cosine squared theta, we will use the chain rule. So first we will differentiate the power. So that will be 2 and copy cosine theta. So that is cosine theta. So after that, we will differentiate cosine theta, but now with the power of 1 because we already differentiate its power, so we're left with 1. So the differential of cosine theta will be negative sine theta times the differential of theta, which is equals to 1. So simplifying this equation, so that will be cosine theta. So 2r times 2, that is 4r, times cosine, that will be 4r cosine theta, times the negative sine theta, so that will be positive 4r cosine theta sine theta. So now we have the partial differentiation of n. So we will find next the partial differentiation of n in terms of r. So that will be partial differentiation in terms of r quantity, r cosine theta times 2 r sine theta plus 1. So first we will evaluate this. To get the product rule, we will just leave r cosine theta multiplied to 2r sine theta in quantity. So that will be r cosine theta times 2r sine theta times r cosine theta to 1. That will be r cosine theta. So now we can use product rule here in these two terms. So first is to get derivative of r cosine theta. In terms of r, that will be just 1 times cosine theta. So that will be cosine theta. Copy 2r sine theta. And plus copy r cosine theta. And get the derivative of 2r sine theta. So sine theta is constant. So we just left with 2 sine theta plus r cosine theta. So simplifying this equation, so multiplying 2r sine theta to cosine theta, that will be 2r cosine theta sine theta. And simplifying this equation 2, that will be 2r cosine theta sine theta plus r cosine theta. So as you can see here, we can add these two equations because they are equal. So that will be 4r cosine theta sine theta plus r cosine theta. So as you can see, we have the same value of the partial differentiation. So we can conclude that m is equals to n. So this is exact dE. So just like before, we will integrate psi in terms of r. So just take note, guys, that psi of r is equals to m and psi of theta is equals to n. So integrating psi of r will integrate also the values of m. So that is integral of sine theta minus 2r cosine squared theta in terms of dr. So and we'll plus or add a value of some function in terms of theta. So I will designate it as q of theta. So here we can evaluate this or find its derivatives in separate terms because it is in two terms. So that will be antiderivative of psi in terms of r dr is equals to integral of sine theta minus 2r in terms of dr 2r cosine squared theta dr plus q theta. So here, the antiderivative of sine theta in terms of dr is that sine theta is constant, so we can put it in the front of integral sign. So the answer will be r sine theta because the integral of dr is r. So, and here we can put cosine squared out of the integral sign because it is constant. So we're left with 2r dr plus q of theta. So in here, the answer will be the integral of 2r. That will be power rule. So r squared over 2. Cancel the 2. So that will be r squared cosine squared theta. So our sign now is r sine theta minus r squared cosine theta plus q of theta. So in order to find the first derivative of q of theta, we will differentiate or partially derive psi in terms of theta. So that will be partial differentiation of psi in terms of theta. Copy the value of our psi function, that is r sine theta minus r squared cosine squared theta plus q of theta. So partially deriving this sine theta here, so r will be constant, r. So the derivative of sine theta will be cosine theta. And r squared here will be also constant, so we will just put it there. And now, as you can see here, we can use again the chain rule. So deriving the power, that will be 2, copying cosine theta, and deriving cosine theta, that will be negative sine theta. And the derivative of theta will be 1. So simplifying this term, that will be r cosine theta minus 2r squared. So that will be positive 2r squared cosine theta sine theta plus the q prime of theta. So in this term, we will equate it to the simplified n. So that will be r cosine theta plus 2r squared cosine theta sine theta plus q prime of theta is equals to the evaluated form of the n. So that is r cosine theta times 2r sine theta plus r cosine theta. So if we transpose this equation here to the right side, we'll cancel r cosine theta. So this will cancel. And if we expand this equation here to r squared cosine theta sine theta, that will be 2r sine theta times r cosine theta. So as you can see, now we can cancel the r cosine theta here. So this will cancel and this will also cancel. So our q prime of theta will be 0. So to get the antiderivative of it, because in our original n, we have no derivative, so we will antiderive it or integrate. So integrating both sides in terms of theta. So our q of theta now will be c. So plugging the value of q theta to our psi, that will be psi is equals to r sine theta minus r squared cosine squared theta plus c. So our final answer will be psi r theta is equals to r sine theta minus r squared cosine squared theta is equals to c. So this is our final answer.